Okay, everyone. Welcome again. I'm Miriam. I'm your moderator for this session, and I'm here with Sam Schifman, who's going to talk about using FHIR with generative AI. Go ahead, Sam.
Yeah, hi. As you just said, my name is Sam Schifman. I'm going to talk to you a little bit about my experience with RAG on FHIR and knowledge graphs today. So my goal was to figure out, could I effectively ask questions of healthcare data and get back useful answers? And a bit of a spoiler, I was able to do that. And today what I want to do is talk you through how I got there. So I wanted to ask this question: how much did a colon scan cost that happened on a particular date? And I was able to get the LLM to give me back a reasonably good answer. I could have done this in a number of ways. One thing I could have done was to fine-tune or train the LLM with the healthcare data, right? There's a number of key problems with that. One is the time and resources it takes to train an LLM, right? Even if you're talking about fine-tuning, it's still a lot of resources that go into that, and doing that for every patient, all their data, and as it changes, getting that into working is really not possible. Another problem is hallucinations. And I'm not going to lie to you and say that anywhere in here I'm going to get 100% away from hallucinations, but I think they're particularly dangerous in that kind of fine-tuning situation. And finally, there's security, right? If I fine-train the model on all the patient's data, there's really no way that I can keep it from answering questions to the wrong person about the wrong patient, right? You can have all kinds of scenarios that try to do that, but we've all heard all the stories about how bad LLMs are about leaking their training data. And I don't think that there'd be a really good way to getting around that other than fine-tuning a model for each patient, which then gets into a huge cost problem. Right? So we really need to supply the data at the time that we prompt the LLM. And we can do that. We can supply all of the patient's data. So here's all the patient's data. I'm not going to make you read all of that, right? I tried that. I supplied that to the LLM, and I asked it to answer my question, right? I got not such great results. It chose the wrong date and gave me back the wrong price. Now, I'm going to go call out to Will tomorrow from Google, who's going to be talking about his own experience doing this. And he's had slightly different experiences, and that's the life of being on the cutting edge of technology, right? Different people find different results. And I'm happy to see that there's going to be progress in this area. But this didn't work out for me. I really needed to chunk the data into reasonable chunks and give reasonable chunks to the LLM, right? And FHIR obviously provides me with a great way to get at particular resources that I want to get at, right? The question is, how do I get at the right resource, right? I can use FHIR to chunk the data, but how do I figure out which is the right resource? Well, one way I could do it is I could bring it into a FHIR server, and then as part of my process, I could actually ask the LLM to write the query to get the data from the FHIR server and then answer my question for me, right? I probably need to tell it a little bit about the FHIR structure and have it know that information, and then I can do this whole process, right? This is not the model that I chose for the demo that I'm going to show you. It's a promising model. I did experiment just a little bit with it. You can see here that I got some kind of reasonable results of asking it to figure out how to get to this data. It did figure out, okay, I'm going to go and find an explanation of benefits that might have that value on it. But I personally didn't pursue this. I think that my theory is that there's some problems in production with hallucinations. If it gets the query wrong, it's going to be pretty hard to tell that it got the query wrong. Now, I had some really interesting discussions with some people who pointed out that it's probably more traceable if this gets it wrong. But, where I went was a more traditional RAG approach. If you can say anything is traditional, that's barely existed a year, right? But I'm going to walk you through this fairly, little complicated diagram. But in order to walk through it, we first really need to understand what do we mean by vector embedding. Vector embedding is a fancy way of saying that we're going to give kind of coordinates to words. All right, so what we're going to do is we're going to take our words, we're going to assign them some random coordinates, and this is across many dimensions, right? And then we're going to use lots of text to push those words that have similar meaning, or at least appear more often close to each other in that vector space, right? So that's going to allow us to take a set of text and say, here's where it should be in this really large multidimensional space. So now what we can do is we can take curated data and we can bring it into the vector index. And in order to talk about that, I'm going to actually start with a simpler data set, right? Okay, so this is just the top speeds of some things, some animals and some vehicles that I looked up, right? And what we can do is we can look at the words here, figure out where they are in that vector space by looking up those coordinates, and get a number or a set of coordinates that represent that particular fact, right? And then we can do that for all the facts, and we can bring them into what we call a vector index or vector store or vector database. You know, lots of different people call it different things. Now we can also take a question, right? And so our question that we're going to look at is, you know, what is the fastest animal? And we can do that same vector embedding on that, right? So we do that vector embedding and we get a coordinate for that question, right? And now we can go to our vector index with those coordinates and say, okay, what's close to this, right? And bring that out and bring all of that together and make that part of the prompt to the LLM. This is actually what I did and ran it through an LLM, and that's the answer that it gave me. So great, we can take FHIR or we can put it in a vector index store, right? One little problem with that, our vector embedding was trained on a lot of text. It wasn't trained on a lot of JSON, right? And a FHIR resource is represented in JSON. So I thought to myself, okay, well, why can't I represent it as text, right? And so I wrote a little bit of code, and at the end of this presentation, I'll give you a link to my GitHub repo where you can go look at this code. I wrote some code that actually took, this is actual code generated text from the observation on the left. And so I did things like, for example, I know that every resource is going to start with a resource type. And so I can say the type of this information in this entry is an observation because it's that's the type of the resource, right? Then later on in my text, I can refer to that observation, right? I can do things like I can say the code for this operation, right? Because I just actually relying on the word code there. And I'm inserting the word the, and then I'm saying the and the property there. And if there were a tree of properties, for example, name, it would say the name given is, right? The name given for this observation is, and that would be a patient resource. So then I get to the is, right, which just kind of replaces the colon. And then I do know some smarts about, okay, I got a code system there, right? I got a coded entry there. I know that that's what's going to appear in an observation. It's a coding. I don't really think that the embedding model is going to care so much that it's a LOINC code and what is exactly the LOINC code. What it's going to key off of is that display text. So I just use the display text. Similarly, I have some understanding of how dates are going to likely appear in literature and things like that. So I'm going to rewrite the date slightly. And I understand enough about English that I'm going to kind of move it so it's the observation was issued on, right, rather than the issued for the operation, right? And similarly, so for value quantity, I'm actually using value quantity there. I understand that because it's camel case, because the Q is uppercase, that's a second word, so I'm splitting them into two different words, and then I have some logic that says, okay, yeah, this is a value, so I'm going to take the value and the units and put them together. So that gives me a nice sort of text representation, and I have code, as I said, that does this on any FHIR resource, right? And I can then bring that into the vector index, right? So that gets us to the point where I can say, okay, colon scan in vector space is close enough to colonoscopy that it's going to get to the colonoscopy procedure for this particular patient, right? But what about getting to the cost? That's obviously not going to be in the procedure resource, right? So what am I going to do? Well, I recognize that FHIR also has inside it all these connections between resources. If you were following along before, that text that I had doesn't actually represent in any way those connections, right? But those connections are there. Now, I could put them in the text by representing that patient subject inside the text inline, but then I get into a question of when do I stop, right? So what am I going to do about that? Well, this is where knowledge graphs come in. So what is a knowledge graph? A knowledge graph is basically just a set of nodes which represent the things and how they're connected to each other, right? So we can say that all of these facts can be represented, and then we can rearrange that slightly and make some really good inferences. So we can say, you know, dog's top speed is 45 miles an hour, and it's an animal, but we can also reason that a dog is not a vehicle, right? So this is a knowledge graph created from a FHIR bundle. I'm only showing the 2 colonoscopies that this particular patient had. I'm not showing you all the resources because that doesn't fit on one screen. You know, if you remember, my question did have a specific date to it, and I'm not going to talk today about how I get to that specific date, but it's there because there's a node that represents it, right? And I'm able to get to the right procedure by projecting each of those nodes into that vector space, right? So if you actually looked here and happen to notice, there's the embedding. Those are the number representations of that particular node in vector space and what allows me to get to that right node. And with that right node, then I'm able to get to the associated resources, which include the claim, which happens to have the financial information on it. And that is how I get to answering this question correctly. So, these are some links to, I have some videos on YouTube that go over some of this again from a slightly different angle. All this code is available on GitHub in a repo that I made public. If you hit my YouTube channel, there's also some other YouTubes there looking at clinical practice guidelines and stuff like that. But that's what I wanted to talk to you about today.
Thanks for the talk. You mentioned at one point throwing away LOINC codes, and I was just wondering, since these code systems have tons of edges and semantics, why you decided to do that? Or could code systems be useful in kind of the process you went through?
So when I was generating that text, I was very specifically wanted to generate that text so that it would work well in an embedding model that I had chosen, which was not medically specific embedding model. So it didn't have anything, you know, like if you looked at the data that it was trained on, the number of times a LOINC code would actually appear in that data was probably infinitesimal. And so I figured that would actually kind of push my results off by putting in that LOINC code. I might as well just put in the display name, which is customized because, so I'm using Cynthia data, so I could rely on the fact that it was properly filled in with the proper display name that came from the code system.
Hey, thanks for the talk. I had a question about the choice to do a traditional procedural algorithm to generate the text versus potentially pumping the resource into like an LLM and having it do the summary? Was the specific structure of the text and the use of the same kind of phrases and structure important for being able to pump it into the vector index?
So the reason I did it as a program has more to do with the fact that I could write that program. I wrote it, I think, in an hour or something like that. And then I didn't have to pay the cost of sending each resource to an LLM just to get back a text representation. That then I would have to be suspect that maybe it hallucinated in the process, and then I'd have to go and validate it all, whereas like I wrote the code, I know it's going to work. I just had to validate it against a couple of examples.
Out of curiosity, have you tried like stemming or taking some of the stop words out and like from your generated resources and seeing if they get equivalent responses back? Would that cut down on cost at all?
I haven't experimented with that. It's an interesting idea to take out some of the words and see whether that has an impact. Yeah, I haven't experimented with it. All right, well, we're all set. There's the traditional slide for feedback. If anybody has some feedback, we'd love some feedback about this talk. And oh, we have one more question right here in the front.
Yeah, just a quick question. I was wondering if you did any experimentation on like accuracy, if you like did any testing with lots of data, or was it just like a few examples that you got to work?
I'll admit it was just a few examples. I don't have any reports of accuracy of numbers that I could give you. That's one of the things I'd love to do at some point, but I don't. This is not my full-time gig, so I haven't had time to do that. And getting a good data set to do that is really tricky, right? One of the things I think that we are lacking in the business at this point are good Q&A questions that involve healthcare data that you could really test a large set on.
Thank you, Sam, for that talk and being nice on time as well. So thank you, everyone, for attending this. Please do give feedback